Have you ever wondered what it takes to send a spacecraft on a successful test flight? What kind of challenges do engineers and astronauts face, and how do they handle unexpected failures? Today, we're diving into the fascinating journey of Boeing Starliner's test flights, exploring both the successes and setbacks. Join me as we uncover the behind-the-scenes efforts that have shaped this remarkable spacecraft. Buckle up, because this is a story of resilience, innovation, and the relentless pursuit of progress. Boeing Starliner, an integral part of NASA's Commercial Crew Program, was designed to transport astronauts to and from the International Space Station, ISS. However, achieving this goal required a series of rigorous test flights to validate the spacecraft's capabilities. The journey began with high hopes and meticulous planning, but as with any ambitious project, it faced its fair share of challenges. Let's start with the Orbital Flight Test, or OFT, which took place in December 2019. This uncrewed mission aimed to demonstrate that Starliner could safely reach and dock with the ISS. The launch was flawless, and the spacecraft successfully entered orbit. But soon after, a software glitch caused the spacecraft to miss its intended orbit, preventing it from reaching the ISS. The issue was traced back to a timing error in the mission clock, which led to an incorrect calculation of the spacecraft's position and fuel usage. This unexpected setback was a significant blow to the mission, but it also provided valuable lessons. The Boeing and NASA teams immediately began analyzing the data to understand what went wrong. They worked around the clock to diagnose the problem and develop solutions. The spacecraft was brought back to Earth safely, and a comprehensive review was conducted to address the software issues. This process underscored the importance of rigorous testing and highlighted the complexities of space travel. In response to the OFT challenges, Boeing committed to extensive software upgrades and additional testing. The next milestone was the Orbital Flight Test 2, or OFT-2, scheduled for 2021. This mission was designed to re-attempt the objectives of the original OFT, with improved systems and thorough preparations. The pressure was immense, as the world watched to see if Boeing could overcome the previous hurdles. The preparations for OFT-2 were exhaustive. Engineers conducted numerous simulations and tests to ensure that the spacecraft was ready for every possible scenario. Communication protocols were enhanced, and additional safeguards were implemented to prevent any recurrence of the previous issues. The level of detail and care that went into these preparations was astounding. Every scenario was considered, every potential issue analyzed. Engineers ran countless simulations, each one meticulously designed to test the spacecraft's responses to various conditions and potential malfunctions. These simulations included both nominal scenarios and potential failures, ensuring that the team was prepared for any situation that might arise during the mission. When the day of the OFT-2 launch arrived, anticipation was high. The world watched as Starliner lifted off, and this time, everything seemed to go according to plan. The spacecraft successfully reached its designated orbit and began its approach to the ISS. But docking with the ISS is no small feat. It requires precise navigation and control, as well as seamless communication between the spacecraft and mission control. The approach is a slow and careful process, with the spacecraft gradually aligning itself with the docking port. Any error in this phase could result in a failed docking attempt, or worse, damage to both the ISS and the spacecraft. As Starliner approached the ISS, the Advanced Autonomous Docking System took over. This system, designed to guide the spacecraft into the docking port, had undergone numerous improvements since OFT. The system uses a combination of GPS, radar, and onboard cameras to navigate and ensure precise alignment with the ISS docking port. Despite some tense moments, where minor adjustments were necessary, the docking was ultimately successful. Starliner's ability to connect with the ISS marked a significant achievement, showcasing the resilience and determination of the teams involved. This success was celebrated not only within NASA and Boeing but also by the broader space community, as it demonstrated the viability of commercial crew missions. This successful docking wasn't just about overcoming technical hurdles. It represented a critical milestone for Boeing and NASA, proving that Starliner could fulfill its role in the commercial crew program. The mission's success provided valuable insights and data that would be used to enhance future missions, ensuring even greater reliability and safety. The lessons learned from this mission were not just technical but also operational, providing a blueprint for future space missions. This success also bolstered confidence in the commercial crew program, reinforcing the viability of partnerships between NASA and private aerospace companies. Following the successful docking, the Starliner crew began their mission aboard the ISS. This phase of the mission was just as crucial as the docking itself. The astronauts conducted a variety of scientific experiments, many of which were designed to improve our understanding of how the human body adapts to long-term spaceflight. These experiments covered a wide range of fields, from biology and human physiology to materials science and physics. The data collected from these experiments not only contributes to our knowledge of living and working in space but also has potential applications here on Earth, such as in medicine and technology development. Additionally, the crew performed maintenance tasks on the ISS, ensuring that the space station remained in optimal working condition. This included repairs, system checks, and even upgrading some of the ISS's equipment. The ability to conduct such maintenance is vital for the sustainability of long-term missions, particularly as we look towards future exploration missions to the Moon and Mars. Each task completed by the crew was a testament to their training and the robustness of the Starliner systems. The successful completion of these tasks demonstrated the spacecraft's reliability and the crew's proficiency in operating it under real mission conditions. The return journey was equally important and challenging. Re-entry into Earth's atmosphere is a critical phase of any space mission. The spacecraft must withstand extreme temperatures and forces as it descends. The Starliner's heat shield, designed to protect the capsule and its occupants, performed flawlessly. The spacecraft executed a precise deorbit burn, followed by a controlled descent and landing. The landing site was carefully chosen and prepared to ensure the safety of the crew and the spacecraft. Upon landing, recovery teams were on standby to quickly reach the capsule and assist the astronauts. The smooth and safe return of the spacecraft and crew was a fitting conclusion to a mission that had faced so many challenges. This triumphant mission not only marked a significant accomplishment for Boeing but also solidified its place in the future of human spaceflight. It demonstrated that Boeing could deliver on its promise of a safe and reliable spacecraft, ready to transport astronauts on future missions. The successful return was celebrated not just as a technical success but as a proof of concept for the future of commercial space travel. The smooth re-entry and landing procedures were critical in ensuring the spacecraft's reusability and long-term viability. This mission set the stage for the next critical step, the Crew Flight Test, or CFT. The Crew Flight Test was a monumental milestone, as it would carry astronauts aboard the Starliner for the first time. The stakes were higher than ever, as the lives of the crew depended on the reliability and safety of the spacecraft. The preparations for CFT involved even more rigorous testing and training. The selected astronauts underwent extensive simulations, familiarizing themselves with every aspect of the spacecraft and its systems. They trained for various scenarios, including emergency situations, to ensure they were prepared for any eventuality. The dedication and commitment of the astronauts and the support teams were evident as they prepared for this historic flight. When the day of the Crew Flight Test arrived, it was a moment of immense pride and anticipation. The launch was flawless, and the astronauts were safely launched into orbit. During their time in space, they conducted a series of tests to further validate the spacecraft's performance. The mission culminated in a successful docking with the ISS, where the crew carried out scientific experiments and maintenance tasks. The safe return of the astronauts to Earth marked the completion of a significant chapter in the Starliner program. It was a moment of celebration for everyone involved and a testament to the hard work, innovation, and perseverance that had gone into the development and testing of the spacecraft. Looking back, the journey of Boeing Starliner's test flights is a testament to the power of perseverance and innovation. The setbacks and failures were not endpoints but rather opportunities for learning and improvement. Each challenge was met with determination and expertise, resulting in a spacecraft that now stands ready to contribute to the future of human space exploration. The successes and failures of Starliner's test flights have provided invaluable data and insights. These lessons will undoubtedly shape future missions and contribute to the broader goals of space exploration. The collaboration between Boeing and NASA has proven to be a powerful force in advancing our capabilities and pushing the boundaries of what is possible. Thank you for joining me on this exploration of Boeing Starliner's test flights. If you enjoyed this deep dive into the challenges and triumphs of space missions, please like, comment, and subscribe for more fascinating stories from the world of space exploration. Until next time, keep looking up and dreaming big. The future of space travel is bright, and together, we will continue to reach for the stars, one mission at a time. As we reflect on these journeys, we are reminded that every setback is a stepping stone towards greater achievements, and the sky is not the limit, it's just the beginning. The story of Boeing Starliner and its test flights will be remembered as a pivotal chapter in the ongoing saga of human space exploration, inspiring future generations to dream big and reach for the stars.